Welcome to the Flying Dolphin Project. My name is Drew Graves and I am the founder of the Flying Dolphin Project. I came up with the idea for this project about 3 years ago. At that point I started working a lot at sea, so I was doing a lot of film work, filming out at sea, and I really wanted to create something that could film under a boat and then take off again. To be able to fly in between the different mediums to film with, and especially as 360 technology has gotten better. We made a 360-degree film last year that was incredible, and we trialed and I guess invented some new methods of filming then. I've wanted to bring forward that knowledge to this project on how we can film underwater. The Flying Dolphin is a UUAV, an Uncrewed Underwater Aerial Vehicle, and the Flying Dolphin plans on breaching the surface of the water and taking flight in one continuous movement.
The Flying Dolphin is a project that aims to create a submersible and aerial vehicle. Very few projects have actually achieved this, so that's what we're looking to develop. I'd say the coolest part is it has the prospect to be one of the fastest multi-medium drones, and also nothing to my knowledge like this has been done in a Western country before. This project will change marine autonomy.
Nice. Is this the motherboard?
Yeah, right now. These are the two drawings at the moment. This is the concept that I've come up with. I'm very happy for it to be ripped apart and for you guys to help me figure out what it can be. Basically a flying V. This this surface area at the moment is enough to lift 5.5 kilos of weight.
At what speed?
At 30 miles an hour.
How do you get there?
I've got a good sense of unbridled confidence when it comes to whatever can be achieved. Of course, I've had moments where I've thought, what am I doing? I'm a filmmaker and I'm doing this extremely complicated engineering project, but I'm really lucky to have a lot of really intelligent people around me. So people that really know their field extremely well. Our primary team is from the university, so we've now got an additional one recently. We now have 5 students from the university who are working on this project. And outside of that, we have a consultancy team of engineers. So through working in the engineering sector, filming, and through friends, I actually surprisingly have a really good engineering network. I think it's one of the benefits of being in Plymouth. Plymouth is an excellent engineering city, and we've got a lot of really great and helpful people that have given their insight on the project, which has now expanded to some of them actually joining the sort of management team and the new development team that's formed out of it.
This, whereas this is the main, which means that.
So did you want to do a motor test then?
I've learned a lot about the iterative design process. I also learned more about some welding, for example, and a lot more maths and science based on everything we're doing. This is helping with my degree a lot more because I got more practical engineering experience, so I can see and talk with other engineers about different things that could be useful to my later career, especially with this kind of project as it's drones. And a side project I eventually want to work on is my own drone. So this helps with that because I can see all the calculations and thought processes going into designing, let alone actually building this kind of thing.
So my degree is robotics, so being able to look at both internal systems and design for an actual thing and thinking about all of that helps a lot, because with a lot of uni projects it's not much care on the design and how it all works, but having to think about power, like how the power from a battery gets transferred throughout with like distribution boards, and seeing it all come together in a lot larger of a system than just a simple little board about this big is fascinating.
At the start of this project, I knew that I wanted this team to be built up of university students. I love the idea of giving students an opportunity and them the ability to experiment and learn. I'm learning all the way through this project, and to be learning with people that are also learning is great. When the interviews were conducted, I really only had one thing that I was looking for, and that was enthusiasm. And that was something that everyone showed in their interviews. Well, it could also be aluminium. It could be, I mean, the reason why I like the acrylic is just because we can see it.
Yeah.
I think it may be worthwhile still CAD, to do basically the entire thing in CAD first. Because then I'm slightly concerned that we'll order the wrong size of acrylic tube or something silly like that.
Yeah.
Because
100%. That's why Eli's now modeled every component.
it should be.
It's all been on GitHub.
It should all be there.
Every single component.
Every single component.
Except for the compression system. So the coolest part about this project is the fact that it's on the precipice of innovation. It's right at the forefront where things don't really exist yet. This is something that isn't commonly seen anywhere. Being able to do something that's right at the forefront of human civilization's innovative technology is just awesome. I've been working and filming in this field for the past 3 years, and it doesn't stop exciting me, like especially in Plymouth. So Plymouth has recently been announced the National Centre for Marine Autonomy, and that is huge. The place where I've born and grew up is now this epicenter for marine autonomy operations, and the fact that we're now positioned in a place where we can take full advantage of that and really become one of the players in the game. The journey this project has taken so far is we started with the submersible body. We had 3 tests of that project. So today's the big day. Today we're doing a test. Well, we're doing our first underwater test of the whole drone. So this morning and recently we've been testing the waterproof end caps for the bulkheads.
Most of what I end up designing is more of the housing for internal components. I also handle more of the things stopping water from getting in. The end caps is what we call it. They literally just go onto the end of either side of the drone, really, of the drone's body, and prevent any water from getting in.
And they work. So we had a minor leakage, which has now been solved with just a little bit of CA glue. There's a hole in the epoxy. We're now going to be putting it together to put into this storage, to put into this pelly case to take over to the testing workshop where there's a nice big dive tank. This will be the first time we've tested the motors underwater. It'll also be the first time we've tested the battery and the motor underwater at a high voltage.
We are putting this in the water, yeah? Okay. We need to have a process in our heads in the event of a fire. The thing that age and experience brings with you is preparation for the worst, because fundamentally, when it goes, like I said, when it goes wrong, it'll go wrong so quickly. And we don't, we have no anticipation of it happening. But if we don't talk about it and have it in our heads of what to do, we'll all be running around like a headless chicken and causing ourselves injuries.
Hello, you alright? How's it going? Good. You're here for probably the biggest moment. It's never been together this much.
Oh wow.
Well, the motor's not actually connected to anything on the software yet, so it won't actually do anything.
Yeah, why not?
It served a purpose for us.
What was it called again?
Yeah, I just wanted to do a motor test rather than run it off that because it's. I mean, it should be RCN4. Which one do we actually plug it in? I think we plug. I'd say the hardest part of making this work from a software perspective is I've not done anything like this before in terms of the integration of the hardware and the software. So my background is being basically purely software. And sort of learning those skills in terms of how to integrate and then dealing with different languages and different requirements of different pieces of hardware, that kind of thing. That's been the hardest part, the integration of the software and the hardware. Give it the...
It's not going anywhere.
Okay.
Oh.
Is that a problem with the motor? Yeah.
Good. What's that?
It would accept control on this main out, but it wouldn't accept control on the auxiliary out. So it was a strange error.
Before this project, I've maybe soldered wires a couple of times. This has been trial by fire. Whoa! One of my earliest solder joints was soldering the motor together, and the motor solder joint failed, and we did not know what was wrong with it.
No.
Nope, that wasn't it.
I'm feeling some disappointment. Yeah?
I'm not disappointed.
Oh no.
There's no disappointment here.
There is no
I was
disappointment.
slightly expecting this.
Yeah.
There'd be some...
It'd be amazing if it worked the first time. I can almost guarantee you it's this battery.
But I don't know why you would have.
I don't know what would have changed.
No.
Fuck's sake. You bastard. Of all the things.
Yeah.
It wasn't until we took the whole thing apart that we actually found the failed connection.
I'm not holding that.
Fuck's sake.
Well,
It's because the salt's come off.
there we go.
That has just happened then.
Yeah.
When I just tightened it up then.
Genshi Genbutsu at its finest. We found the root cause. Ideal.
So I can just see a terrible solder joint there as well.
It's a real shame.
That really does explain it.
The thing that keeps me motivated is the enjoyment of the iterative development process. I like seeing how it develops over time in terms of trying something and it not working, but then we come up with a new idea, or this may work, and then we test it and we try and develop something. And seeing that process over time is very interesting, and that's what I find motivating about it.
I found the tests were pretty exciting because it means you can see what's gone right, what's gone wrong, and go from there. Because it's always fun trying to figure out what to do, what needs solving and everything. As I personally like a lot of problem solving. I like puzzles, and the tests reveal a lot more data.
With models, you'll find components with like boxes. They've also got the cables. You need to think about the cables, where they go, and how everything does fit together. And also the sizing looks very different in real life than it does on a laptop. The surprising thing is how much you have to think about the very specific things. So with the underwater one, you have to think, okay, how do we stop water getting in while still being able to communicate and use things on the outside?
When you optimize a product for air, it looks very different from when you optimize a product for water. And so trying to create a merge of those two in one thing is quite difficult. So that's the core problem that we're trying to solve.
Much flatter. And that's what you've got to do. You just got to have all the right. I was going to take Starlink over. Get all the old videos.
Today we have the latest iteration of version 0-1, the underwater module. A lot's changed. We've gone through many iterations of the end caps. I think we finally have something that should seal correctly. This is the most confident I've been about them throughout the whole project so far. We've also minimized as much exterior access to the pressure vessel. So there is literally just two things going in, which is our data cable and our power cable for the motor. The new motor mount has been built out of stainless steel. Much more confident about this. It's much more stable. It also helps in binding the end caps to the vessels. All this has changed as well. So Arden has redesigned the whole interior structure. We've got a much simpler version. It's now just 3 components. It's 2 parts here for the battery tray and the BMS and power module. The main thing we are testing for today is, will this motor push this 12.5 kilo weight? Hey! Look at that seal. Oh, that's the best seal we've had yet, that's for sure. Perfect. Right. Are we ready? Yeah. Yeah, I was only a little bit. Yeah, I think that was alright. No, no water. Look at that though. That's waterproof. Oh, that is a massive relief. Got a boat now. Oh, this is fun. Yeah, we'll wait for him. Whoa! Whoa!
I mean, this will definitely launch out
We tested it around 20 to 50% throttle, and it was absolutely rapid. It was too quick for the tank.
I'd say what I'm most proud of so far is just as a team that we were able to create something that was able to work underwater and not leak.
That's great news. That's cracking. Cool. So,
Proof of concept.
so chuffed with that. That's going to launch out of the water. And that isn't any different in weight to what the plane will be.
Really?
That's the same weight.
There you go.
So
Maybe a kilo difference. Oh, it's such good news. So an idea I had in this project to get the interns and myself understanding flight and understanding other methodologies of creating winged craft that exist already was purchasing a glider and doing an online course on building a specific 3D printed glider, but both of which failed miserably.
No, it's going again. It's going again.
Definitely need a fire extinguisher. That LiPo's going to go.
I managed to puncture the battery. I basically I put a steel bolt right through the battery, and I just didn't check it at all. We got there on site, put the bolt through, and I had to run and get a fire extinguisher. That was stressful. But we did it safely, we handled it safely, we disabled the battery. We were in probably the most perfect environment, a big open space, everyone was away anyway, and thankfully it was all right. Now, the first flight test taught us so much.
Oh, Paolo and I decided that FMU stands for forget my usage, because just don't use that one on this board.
Can you pitch up?
Pitch up.
Pitch down?
Pitch down.
Cool. Top left. Top right.
The flight test was definitely the most stressful. It's getting it to that point of being ready for the flight test, because a lot of it we had originally planned of a shorter timeline, and that's extended. The flight test was stressful because it was the pinnacle of everything, just to see if it could even work.
Right, that looks like it's going, yeah. That's the right setup, so. Right, are we ready then?
Aye, aye, Captain.
Aye, Captain. Okay. That's so funny. I'm happy about this.
Good.
Because it means that we've learnt a lot and
Yeah.
we can redo the whole thing.
Yeah.
Because none of this is staying the same. We learnt a lot. It crashed, but it crashed really well, and we learnt a lot from it. We've got lots of footage of it.
I didn't think it was going to work. I genuinely didn't think it was going to work. It's the fundamentals were there. I think a key factor was not enough runway. And we've broken down now and analysed the video with a load of different engineers as to what all the problems could be. I think the main one is not enough speed, not enough lift. The runway was elevated, which basically allowed it to really savagely crash. I mean, it's right there. That is the nose broken in pieces on top. Weights weren't fixed inside it. Loads and loads of issues. But we've learned from all that, and now we have an aeronautical engineer who has joined the team, and he is working on the new aeroframe along with some other engineers.
When it didn't work, it was a bit stressful, but it's the fact that we got the data that we need to fix that and then combine it with an underwater prototype that's the most important. I'm excited for the next test though, to see what we can do from there.
I'm really looking forward to our next test. So our next test is going to be our breach test, and we are going to be testing our V1.2. V1.2 is awesome, and it's what all of this kind of has been working towards. From what we can see so far, it is rock solid, it's a submarine, and that's it. It's just a submarine right now. And that submarine will be our base for our aeroframe. And I'm desperate to see it breach out of the water, and I know it's going to do it.